You now understand the purpose of using parallel link, or p-link for short. How about we jump into Visual Studio and look at how we can construct a sequential query that is then improved by introducing parallel link.
We'll use the same base for the console application that we experimented with in the previous module. The code will calculate the amount of time it takes to execute the main method. Using this will give you an understanding of how much better, or in some cases worse, the execution of the code gets. As a side note, there are alternative tools to analyze and profile parallel operations. There's an extension to Visual Studio that you can download called Concurrency Visualizer. I'd really recommend you experiment with this on your own. In our console application, I'd like to do sort of the same thing that we've done earlier, but instead of iterating from 0 to 100 with a for loop, I'm going to first generate a list of numbers. We can do this by using enumerable.range. This generates a sequence with numbers ranging from 0 to and including 99. This gives us a bit of data to work with. The goal is to call compute and pass each item from this sequence to that method. Then we'll get the sum of all those operations. This is effectively the same thing we did earlier with the for loop and the lock object. Constructing this link statement using the method syntax makes it clear what we want to achieve. For each element, we select the result from the invocation to compute. Then each of these results will be summarized. As there's nothing in the code that's currently running in parallel, it makes sense that computing this result of 5,000 takes a bit of time. In fact, it does take the same amount of time as we've previously seen in the course. To speed things up, we'd like to run the calls to compute in parallel. This requires us to construct a parallel query, which you can achieve by adding a method call to asParallel. And you do this right before the select method call in your query. This means that the select will operate on a parallel query, and compute these values should in theory be much quicker. We've got a fair few elements to process, there are no side effects of calling compute, and each invocation to compute is completely independent. With all of that in mind, do you think this will run faster? Will this run the query in parallel? How about we run the application to find out? It definitely ran a lot faster. On my machine, this runs about 20 to 25 times faster than the sequential operation. We even got the same result, which means we indeed made sure that we improved the performance of the application. This also means that this query did in fact run in parallel. Rather easily, we changed the sequential query to become a parallel query instead. Now, instead of selecting the sum, I'd like to grab the first 10 elements produced by the query. To do that, we use the method take with the given number of elements that we'd like to grab. If you iterate over each of these elements and print them to the console, which elements do you expect this to print? As you can see here, these elements are not printed in order, which makes a lot of sense because the parallel query will start the operation in parallel, and you have no control over which elements are processed when. However, there is a way to persist the order of elements, and sometimes the order of the original sequence is important. After the call to asParallel, we can instruct the parallel query that we'd like to treat this as an ordered sequence. As a word of caution, this will add a bit of overhead. I'd also like to mention that this does not execute anything sequentially. It only means we'll be persisting the order. Another important point to make here is that when adding take, it won't limit the parallel operation to only 10 elements. Compute will definitely be called more than 10 times. I would suggest that you set a breakpoint in compute and experiment with that on your own. With as ordered being added, this means that when we take the first elements from the result, and when this is printed, we can see that we now get 0.5 to 9.5. We persisted the order of the elements. And you know what's great? We did this without any drastic change to the performance. It still takes about the same time to execute. The query is now running in parallel. Each element is being processed by a time-consuming operation, but we greatly improved the performance. Even if the order is important when we are grabbing the 10 elements, when we then process the 10 elements, that might not have to be done sequentially. After we've gotten the result, we sequentially iterate the sequence using a normal for each loop. We could, of course, introduce a parallel for each if we'd like to process this ordered list of items. However, the parallel query also exposes a method to make this a little bit easier for us. Instead of running the for each loop, you can call the method for all, together with either an anonymous method or pointing to a method for it to invoke. This will ensure that the query is executed, and for each element in the resulting query, we run the method passed to for all. This means we can have a truly parallel processing of the elements. Nothing in the code is now processing the list or the result sequentially. You can see that we still have all the elements, even though they were not printed in order. You persisted the order of the elements in your list, but then you could completely process each of the elements in parallel. With this, we've now introduced a parallel query. You can apply this to your own link statements and experiment with how this impacts the performance of the application. As a suggestion, you can now experiment with adding the method with cancellation, as well as with degree of parallelism to the application. It will behave just as like we've seen previously, and it's a great addition to parallel link. Converting link to become parallel might seem as easy as adding as parallel. However, you shouldn't forget that the parallel query will analyze your query and what it's performing, and there's no guarantee that it will run the process in parallel. Therefore, you should try and apply this in your particular situation and see how it impacts performance.
But as you've learned throughout this course, there's much more that you need to consider to make sure that your applications behave exactly the way you intended to.
As mentioned earlier, depending on what your query is doing, it may force to run sequentially. This is something determined by the parallel query. To help you determine this, here's a list from the Microsoft documentation on what to look for and when the parallel query will choose to run sequentially. If you are finding that your parallel queries are choosing to run sequentially, you may only need to refactor your code slightly to make sure that it runs in parallel.
You now have a good understanding of how to build multi-threaded applications using the different components of the Task Parallel library.